Okay, let's look at this problem. We have a recursively defined sequence, and we're trying to find a closed form expression for the sequence. So first off, let's figure out the first four terms. So a sub 1 is given in the problem. If n equals 1, then the first term is 1. A sub 2, by definition, is equal to the first term plus 1 plus 2 times the square root of the first term. So that'll be 1 plus 1 plus 2 times the square root of 1. And so that is 1 plus 2, or 1 plus 1 is 2, plus 2 makes 4. A sub 3. By definition, if I replace n by 3, I will have a sub 2 plus 1 plus 2 times the square root of a sub 2. Again, if n is 3, then I have a sub 2 there. So that's equal to 4 plus 1 plus 2 times the square root of 4. That's 5 plus 4 makes 9. And the fourth term is a sub 3 plus 1 plus 2 times the square root of a sub 3. A sub 3 we just found to be 9, so 9 plus 1 plus 2 times the square root of 9, which works out to be 10 plus 2 times 3, which is 16. All right, the pattern hopefully is clear. That looks like a sub n. So our conjecture is that a sub n is equal to n squared. And so that's what we will attempt to prove, that a sub n is equal to n squared. To do this, we will use mathematical induction. So we're going to show theorem that a sub n is equal to n squared. Proof will be by induction on n. First, the n equals 1 case. Well, the n equals 1 case is simple. A sub 1 is 1 by definition of the sequence, and that is clearly equal to 1 squared, which is true. So the base case of n equals 1 works. N equals k. We'll assume that a sub k is equal to k squared. So that takes us to the n equals k plus 1 case. Okay, so to do this, we start on the left-hand side, a sub k plus 1. On the right-hand side, we want to end eventually with k plus 1 quantity squared. And if I can somehow do that, I'm done. Now the work is going to be filling in the blank space there. If I replace n by k plus 1, then we have a sub k plus 1 plus the 2 times the square root of a sub k. And again, I replace n by k plus 1 in all these expressions. By induction hypothesis, a sub k is equal to k squared. So k squared plus 1 plus 2 times the square root of k squared by induction hypothesis. Okay, that's equal to k squared plus 1. Now, one technical detail here, the square root of k squared is technically 2 times the absolute value of k. Because if k is negative, the square root of k squared has to come out positive. But because k is known to be a positive number, right, because k is going to be 1 or higher, then we can get rid of the absolute value signs. And then k squared plus 2k plus 1 factors is k plus 1 squared. And so that is the end of the proof. And so we have shown by induction that a sub n is indeed equal to n squared.